everyone. Thanks for joining today. We are going to talk about mission-ready operations and how you can make that happen through continuous improvement and compliance in aerospace and defense. So today, I will be joined with Kaylee Crothers, who has been here at Tulip for about 5 years now. She leads the technical sales team and has lots of experience working specifically with manufacturing operations and to help support them solve the problems that they deal with every day. I'm Michelle Volo. I'm the head of quality here at Tulip. I've also been here for about 5 years. Lots of experience in regulated industries and now working with Tulip to help regulated industries move through these very changing times. So today's agenda, I just wanted to give you a little roadmap of what we're going to go through today. We are going to start, or actually Kaylee's going to start us off with a view of the current state of manufacturing. Then we'll jump into some of the problem statement and some of the barriers to becoming agility in today's manufacturing environments, especially in regulated spaces. And then we'll talk a little bit about the shifting to a new approach, what this actually means, both from a theoretical point of view and also from a tactical point of view. And then, of course, get into some great live demos as to how you can do this in your space.
Thanks, Michelle. So to hop right into the state of manufacturing, we have seen unprecedented market volatility across all industries, but most notably aerospace and defense. So there's some stats here showing that. I think one of the most important ones are the 77% of manufacturing leaders are confirming that trade uncertainties are their number one business priority. In addition to that, we have some other trends here, like nearly a 10% increase in military spending from 2023 to 2024, and that's a global number. So that shows the steepest year-over-year growth since the Cold War. So a lot of just changes and uncertainty out there in the market that we've all been experiencing, and from the looks of it, will continue to experience.
Thanks, Kaylee, for talking through that. Those are really great metrics that you shared with us. So let's talk about the human impact on manufacturing, because any manufacturing environment, there's humans in the center today and in the future. That will still be the case. So there's a lot of things that are happening right now that are really affecting the manufacturing environment. The first one I wanted to talk about really is the retiring workforce. We have lots of people who are retiring from the workforce, people who have been in their current positions for many, many years. And what's happening is this knowledge is being lost. If you think of a pre-digital era where not all this data and information and ultimately knowledge was stored in a way that could be transformed or transferred to the next incoming workers. So this is becoming a problem. Also, the new generation, the average tenure of the new generation is about 1/3 of what the previous generation was. So to capture this knowledge and information and maintain a state of control is going to be really difficult as we move into this new era. Also, another interesting metric, 70% of Gen Z employees would switch their jobs for better technology. That's a really good indicator that people are looking for better tools to perform their jobs. So as you can see here, this is just sort of a very generic view of a manufacturing operational space. What you see is the challenges that manufacturing operations are facing are varied and very complex at the same time. What we also do know is that every manufacturing facility is unique, but we do know that these problems are throughout the facility. Changing to this new approach is that we need to start realizing and understanding that these problems are not siloed, they're not on their own, and they have very much interrelated relationships oftentimes. So for example, a issue maybe at one part in your manufacturing operation where a particular part or material is defective. In order to continue manufacturing, oftentimes you might have to stop your line, call a supervisor, get somebody from inventory management, get a new part, and then bring your line back up. That oftentimes takes a really long time. With much more of an integrated approach to solutions and solving problems, these downtimes and outages can take much less time. So what does that mean? Agility is critical for resilient operations, is what we're trying to say. And agility it's just a word describing shorter, faster, quicker, changeovers and ability to adapt to what's happening in your environment. So imagine, like maybe the scenario I said, or maybe another problem that you're trying to solve in your shop floor. Imagine right now how much time and resources it would take to incorporate that change. Before doing anything in your environment, then you have to understand all the risks and also the confusion and errors that the frontline operators may face. Are there, I don't know, training issues? Is it disruptive to your plant to make these changes? And how much time would it take to find and mitigate any resulting issues, any side impacts of making those changes? So, what we want to do is try to shift ourselves towards a more agile working environment where changes can be made much quicker in smaller doses. So, in comes continuous transformation. The last few years or even decade, you maybe have started to hear a lot about digital transformation. I'm sure, like wherever your sources of information are, there's hashtags, digital transformation, and that's everywhere. And that's not a bad thing. But what we're trying to do is shift our mindset towards something that's more continuous, right? We want to be in the state of continuous transformation. What comes to mind is Darwin, right? Those that can transform will survive, right? And it's the same thing, same operating principle in a manufacturing environment. So let's take a look at what we actually mean, right? This is taking this from a very, very theoretical idea down to what this tactically means. So continuous transformation versus digital transformation. We're going to take a look at this in a few different sort of aspects, from scope to end state, with a few things in between. So first and foremost, like let's take scope. So when you're scoping out a project of a digital transformation project, these oftentimes are a defined project that you spend a lot of time upfront defining the requirements, figuring out how you're going to implement it, going through a lot of times operational change management. All of these things are really good and are aspects that we should consider for sure. But when you kind of shift your mindset towards a more continuous transformation environment, you focus in on defining the problem and executing now. What that means is defining one problem, maybe one small problem, one maybe small integrated problem to something else, solve that problem and move on. We're not looking for a big bang here. We're looking for small wins and small gains, but on a continuous cycle. This does rely upon a shift in mindset, of course. This is very much a cultural shift towards something that we're in this perpetual state of change. Again, this is a really great activity. So, like once you're in this perpetual state of change, it becomes sort of a defined muscle maybe that you have, right? Because you're continuing in this state of change and able to make updates more quickly. The focus also shifts. The focus is shifted maybe away from specific technologies or digital strategies towards emphasizing sort of the agility and the learning and the incremental improvements. So it's again, it becomes much more of a focus on the problems you're trying to solve versus implementing a technology for the technology's sake. This will result in faster improvements. And at the end state here, this is something that it's not necessarily, it's not about the destination, right? It's more about the journey. This is really like you may not know that you finished because you're in this continuous state of change. And this is really, again, just kind of a changing of a mindset as to being able to adopt this sort of approach. So, going back on the topic of digitization isn't enough. I think I started there. Um, and what do we mean by that? Ultimately, we want to be resilient, adaptable, and continuously transform. I think you've heard that already. There's this concept of composability. This may be a new concept for some of you, but it's a concept heavily used here at Tulip. You can see on the left-hand side is an example of probably where you might be today. We are digitizing with point solutions. You hear a lot of three-letter acronyms about a given set of capabilities and functionalities of a given tool, like an MES, for example, is a manufacturing execution system. The focus there is it provides functionality to support the manufacturing floor, and that is it. The focus is there. What you see on the right-hand side is a bunch of interconnected bubbles. And this is also kind of parallel to the concept that I talked about earlier, where the problems are most likely all over your shop floor in different areas. Well, if you have a platform approach that enables you to composably build out solutions and in regulated environments validate those solutions and make those solutions live to your frontline operators in a composable manner, this enables and fosters that environment of continuous improvement, the agility that you want, again, focusing in on smaller problems, solving for that problem, deploying and moving on. The other sort of side benefit of this and these composable platforms is once you grab or store particular data set, that data set can be used elsewhere in the value chain of your manufacturing operations. It can be used upstream, it can be used downstream, it can be used throughout your plant. Analytics are available, all those great things. So really, it's not about the digitization, but how and what you're digitizing. And again, that mindset is ultimately very important. So taking it one step further is what can this really look like on the shop floor? So what you're seeing here is at the top, I want to start in the circle. A circle is a circle. It's a continuous loop. But let's just start at the top. These connected apps to power your operations. In a solution like Tulip, where it's a no-code app building platform where you're building apps to solve specific problems, you can create those, start collecting data, and analyze without even writing a single line of code. What that means is that it's not just your IT departments or your teams that potentially might have computer software degrees or computer science degrees, but it's those process engineers that have the most intimate knowledge of the product, the processes that are supporting your products. Those folks are the folks that know the most about those processes, and they can build out those applications in a way that helps your frontline operators. The very next step you see here is frontline feedback. That means these process engineers are working directly with the folks on the front line to get that immediate feedback about this solution solves my problem. This solution would be better if it could do this or that, and immediately feeding that information back into the continuous improvement loop. And also at the same time, getting real-time process data as a result of executing these processes. And this becomes a very powerful loop for engaging and executing a continuous improvement environment. So I've talked a lot about theoretical. I've gotten a little onto the beginning of a tactical side. I'm going to hand it off to Kaylee now so she can show you some real-life examples and then get into some demos.
Thanks for that, Michelle. So taking a look at some various manufacturers that have all faced their own challenges and unique challenges in such a volatile market. You can see here from opening a new production site, facing quality issues, the need to expand capacity. All of them were able to leverage the power of a composable platform to solve those unique set of challenges. So double-clicking on one manufacturer specifically, Airborne. They're an electronic supplier for aerospace and defense industry. They do mostly connector and cable assemblies, so a relatively manual process. Their number one problem was quality issues, and they kind of had a multi-phased approach to target that, being able to leverage the agility that a composable platform offers. They first started on the digital guidance and work instructions front. So how can we provide operators more human-centric, detailed workflows on how to do the task at hand? Then in addition to that, they started standardizing how they capture defect and rework information. So being able to look at your data through one lens. Is that standardizing reason codes for you? Is it, we've all seen the Pareto that has 5 different categories that are just typos or different capitalizations of the same thing. So really getting their arms around where their issues were coming from and exactly what those issues were. And then they took that a step further and attacked introducing more inline quality checks and just error-proofing measures. They were able to leverage the open connectivity of the platform by actually integrating to a scale and getting real-time feedback if something was in or out of an expected range. All of this led to 30% reduction in scrap. And there's a really nice quote here: quality is everyone's responsibility mindset. So being able to take all of those players involved in this process and provide them with solutions that A, give them the data that they need, but then B, give you the data that you need as well, all led to this really nice scrap reduction impact. Okay, let's transition and start to take a look at a little bit more of the platform. So here we're looking at an overview of Tulip's composable MES specifically for aerospace and defense. So this is a collection of templatized applications. You can see there's 4 different categories. So we have templates related to traceability, related to quality or frontline QMS, as well as production management, as well as inventory. So 4 different categories of templates that all kind of together work in concert as a composable MES. What's really unique about these templates is that depending on your unique challenges and where you might be looking to get started with Tulip, you can cherry pick what those where those issues come from. So let's say on the production management side, you're struggling with communication issues on the floor, not understanding what's actively WIP, are we winning or losing today, just some really basic performance baselines you're trying to nail down. You might be starting with more of a performance visibility terminal or a little bit of production tracking. You could also leverage the end-on terminal. All of these applications lie on top of the Tulip Common Data Model, which is a collection of pre-built defined tables or a data structure that you can then take and iterate on top of. So they're intentionally basic and intended to be changed to fit your unique operation. Really good example of that would be a defect table. It's going to have some basic things that regardless of what it is that you make or the type of operation you run, you probably track with a defect. Unique identifier, who reported it, what was the serial number, what is the active status, and you can then take that table and expand on it as required. Also very important, all of these templates can be kind of a take what you need, a menu, if you will. So any of these functions that you would need to push or pull data from an existing system. So probably the most relevant ones would be your ERP or the system that manages work orders or inventory, as well as other systems like a PLM or a QMS. All of these can be integrated to Tulip to push and pull data from other sources of truth where that's required. So taking a look at all of these templates, we can look at a simulated factory and how you might download them and iterate them to kind of show the simulated environment. So here we have all of those templates working in concert together through some machining processes, fulfilling let's say like a warehouse or a kitting environment that then flow through assembly, inspection, all of your quality workflows, having an MRB, an application, as well as supporting rework, all the way through the generation of your device history record or any of those compliance requirements. So let's take a look, let's say, at the regulated assembly application. I'm going to pull open the Tulip player. This is what runs applications, device agnostic, and we can go through the experience of what an operator might see here. So we have a list of units here. These could be work orders. These could be jobs. I could have barcode scanned, let's say, a label or a traveler, or this could be coming directly, let's say, from an ERP. So I've selected my work order. We can just kind of simulate a barcode scan there. I see some details. And I'm going to move through a assembly process. Before we get there, we're going to confirm that my kitted components are correct. So this could be doing a BOM verification, let's say against a PLM. This could be a data definition that lives in Tulip. Tulip is a kind of come as you are in terms of your tech stack. So if you have robust systems with source of truth for data elsewhere, Tulip can be pointed to those for reference. So here, as we're scanning, let's say all of the components that are kitted at my station, you can see that all of those items turn green, denoting that they were correct. Assuming we have all of our correct items here, it's going to dump me into some work instructions. So work instructions can look and feel many different ways. In this scenario, we have some GIFs. We could also have PDFs, images, videos, and we have some checkboxes here to confirm that someone's following the process. You can see how this is error-proofed. If I don't check all these checkboxes, it's not going to let me move forward. You could error-proof also on top of device outputs or using more advanced, let's say, AI with computer vision, a whole host of different levels and maturity that you can strike there. So let's assume that we've completed our work instructions. We can finish our assembly. That might update, let's say, our ERP, that this order, has now moved on. And it's also maybe going to create a queue for the next station, where in this case, there's an inspection station that's going to, await this material. We're then prompted to print a barcode, and we can do that. And we're back to the beginning to work on our next order. That's a very basic workflow that you might build on top of one of the library applications. We took a look at that app from the back end. What I'm opening now is the Tulip editor. So this is the no-code environment where you would pull down that library application and edit it as required. So as an example, let's say the scan work order step here. Everything here is just drag and drop. So in terms of instructions, if I wanted to add an image of something, if I wanted to add a CAD file, I could just directly select this, drop it where I need it, configure it. Very similar to building out a PowerPoint. Taking a look at, let's say, the no-code side of things, here's a step to log a comment on a work order. We have a very simple input of a issue description and a simple input of a image related to the issue. If I go on this log comment button, it's just a very simple when if then else structure. So when the button is pressed, evaluate some if, execute some then. Or in this case, we are creating a table record of what this comment is associated to the work order. So it's just using very simple drop downs. So data manipulation, store the status of new into the comments record that we're creating. I could also, through this no-code logic, do very simple things like send emails and texts, or more complex things like interface directly with devices, machines, or systems through connector functions. We understand that composability might be a new concept, and the idea of building your own systems internally might seem a little bit daunting. So the Composable MES offers really a foundational set of applications, pre-built, configurable, and adaptable. We've leveraged our experience of working with hundreds of customers. It is based on human-readable, common data model that you can configure to fit your unique needs. We also have self-paced learning, a community, a lot of various types of resources, including a professional services organization that's here to help you in your journey.
Awesome, Kaylee. Thanks so much for the demo. Yeah, we have time for a few questions. Let me look. The first one I'm seeing is, how can we integrate composability into our existing infrastructure without disrupting workflows? That is an interesting question. I guess I would start by saying, composability is sort of a concept, right? And you'll come across solutions that are composable and maybe not so composable. I talked earlier about sort of more point solutions that are like something that provides you or describes a particular set of functionality for a particular use case or a particular problem you're trying to solve. Not to pick on MES, but my example earlier was MES, like a manufacturing execution system is not a composable solution, right? So you want to go towards something that enables you to solve many different problems, and also not in a big bang sort of style, but rather more sort of one-off type solutions. So you can look for solutions that are composable. We have other webinars and such that talk in much more detail about composability, but first, you want to make sure your solution is composable and enables you to do these things on much smaller scale and solving a much broader set of problems. So you want to make sure you're purchasing a composable solution. And without disrupting workflows, it's kind of interesting because that is sort of the point of this composability, is it enables you to do this without disrupting the workflows. You might choose one very small particular problem, build out your solution for that problem, implement that, maybe get a few champions, get a few people that love the solution or whatever. Then they kind of help foster sort of building out more and more solutions over time. These composable solutions are expected to be less disruptive.
We have a question here. How can I effectively pitch digital transformation efforts to my leadership? That's a great question. One thing that we probably didn't cover in too much detail is the implementation approach when you have something like a composable platform. You're not, starting a journey with a large monolithic solution that takes a year and a half to first just collect requirements for, talk to all the stakeholders, design, build, implement, et cetera, et cetera. With Tulip, you can start with a very small set of problems that you're tackling, and you can take a value-based approach. So when pitching digital or continuous transformation, it's about solving problems. It's not bringing in technology to bring technology. It's about, what are those unique challenges that your business face that I'm sure you're, the most intimately aware of in using technology, to solve those problems. So I would start with, what are those most pressing challenges, or where can I get the highest value for the medium amount of effort?
Another one is, what metrics or KPIs help justify investing in this type of transformation? Um, this one's also interesting. Part of this is about a mindset shift, right? It's not necessarily that you are building out metrics or KPIs specifically for a different type of transformation, but it really goes back to, what problems are you trying to solve? The metrics or KPIs that I would build out are, these are all the problems we want to solve. They are coming from different parts of our manufacturing operation. They might be coming from a lab or a small scale production area. They might be coming from your inventory management, maybe your deviation or out of specification management or things like that. And you want to classify those problems individually. The idea with a composable solution and actually investing in this type of transformation is about demonstrating that you can solve many different problems with one solution. And also, this transformation is about sort of this continuous improvement and the fact that you can get value much quicker. Also, just kind of thinking of another point on this is that this type of transformation, remember, it doesn't mean that there's a specific end goal, but you are solving problems in an iterative manner. The idea is that you will be able to get value much quicker and iterate faster. Okay, I think we have time for one more. What are the first steps to take when moving from a digital to a dynamic operations environment? Yeah, well, I think a lot of this has to do with operational change management. So there is a cultural shift here. I think we're very used to, in industry, certain ways of operating. We're used to, we're going to do this. We're going to build out a huge project plan. We're going to execute to that project plan. When the project plan is done and we've met all the deliverables and milestones that we defined months, maybe years ago, then the project is ending. We want to get out of that mindset and into this more dynamic operational environment. A way to do that is to start managing for smaller groups of change. So what you're going to want to do is pick, I don't know, maybe high value, low hanging fruit type projects, and see how quickly you can get one piece of that done quickly. And that's really is something that can help you build out some momentum, enable sort of more change management, operational change management. Like I said, also try to develop some champions. And those champions should be operators or people who are very close to the operations who are going to be using these tools on a daily basis. Those are the folks that you want to try to help manage through the change. All right. Thank you, everyone, for joining. There's so much here to talk about, and I personally could talk about this for a long time. So we'd love you to continue the conversation with us. You can visit our website. There's a QR code here. You can schedule a personalized demo. Many ways to reach out to us. So lastly, I thank you for your time.